Okay, hi you guys. Good to see you, John and Lawrence. Glad to be back for another quick podcast. How's everybody?
Doing good in the warm air.
Yeah.
Totally. Yeah, it's spring. Spring has sprung. That's pretty awesome.
We had a nice sunny day yesterday, and today
good.
that's
Good.
nice.
Well, I'm pretty chipper for a change. So.
Yeah.
All right. Well, there's a couple of things that we've kind of been hashing around a little bit before we went on air, and I'd like to just kind of continue the conversation. We've been talking about things like when the AE map and model started really breaking apart finally, and people said, "Well, we don't need a map, we don't need a model. Screw that. We just need to focus on curvature, and we need to focus on the things we know." Like, the horizon line is always at eye level, no matter how high you get. And where's the curvature? And the same arguments that we've heard that sort of came in. I remember where's the curvature came in immediately as a flat earth proof a couple years ago when this whole thing sort of really started ground swelling, even though it didn't come from the ground. And so, I have a question for you guys, and I'd like to hear how you describe whether or not we would ever see curvature on a flat earth or a globe, and how important is curvature as opposed to the concept of the line of convergence, or otherwise compared to the horizon line, and why it's always flat and why it's always at eye level, and why no matter how high off the ground you get, it's still at eye level. So I want to sort of break some myths here, because I've noticed quite a few Glober accounts on YouTube have been making videos about things disappearing below the horizon line, and you're not going to see the curvature, but that's what's happening, so on and so on. So, John, I'm going to start with you, and I want you to help the dialogue by explaining what you think is happening with line of convergence, horizon line, why it's always at eye level, why we don't see any curvature, and why that's kind of gotten to be a mythological flat earth myth dogma thing.
Wasn't it funny how they always talk about where's the curvature? Where's the curvature? Guess what? There is none. It's flat. We see this as you have been talking about, especially with your boat on the horizon of the water video. You have this band, and it's a band of reflection, refraction, compression of light going through all the layers of atmosphere at, as you were just talking about, the center point, or the bottom plane of the plane of convergence. Really, I'll call it the plane of convergence right now. So it's normal with two eyes that are right at this level that we see in this binocular but planar horizontal leveled view. Yeah, leveled.
So when something disappears below this line, like the bottoms of buildings, the bottom of the boat first, the shoreline on the other side of the lake, for example, what do you describe as what is actually happening? It has absolutely nothing to do with curvature, has absolutely nothing to do with the angle of the ground getting lower away. How do you describe what has happened?
Well, it's funny that I was just thinking about this. Really haven't thought about it in these terms, but we talk about the lens and the prism all the time, and it's sort of like the light going through the prism. If you look at it the reverse way around, you see all the rays of the different colored light going into a prism, and then they converge to a single beam, or out. So it's like a plane of convergence, compression. You're never going to see past it. You're always going to get that melding of all the different light waves.
Right. So when someone says, "Why can't I stand on the top of the Empire State State Building and see the Bahamas, which somebody actually said to me in a comment the other day, or why can't I see from Florida to Texas across the Gulf of Mexico even, then, it seems like flat earthers are constantly making excuses. Oh, we can't see that far. The eye only sees 3 or 4 miles before, it just sort of craps out. And then when you get a telescope, the telescope lets you see a little farther and brings things closer into view. But at the same time, I've tried looking through telescopes across water, and if there's any heat at all, you can't focus on anything. It's just wavy lines and water in the air and the whole thing. So you can't look very far over water with a telescope. They're designed to look up at the stars. I mean, that's really what they're for. Or the what's it called? The spotter's telescope that is designed to look over great distance of land, but that also only works for so many miles. So why can't you bring the sun back when you look at a sunset and it's just about to hit the water, and why can't you bring it back when you zoom, when you can bring the boat back? Well, obviously we're talking about much greater distance, and the sun is not exactly a physical object. So you can't bring back something that's just light. You can't make it travel further. You can't focus in on it because it's not a solid object. It's just the light from it. So anyway,
and the scale at that distance, yes. From exactly. What we are perceiving its height is above the Earth is, that it just doesn't compare. It's going to get lost into a very quickly, especially because of the bending of light. So
okay, and so here's what the line of convergence does. Okay, here's the sky, and here's, let's say, the water. Okay, let me get them real close. Let's try this. Okay, let's see if I got it on here. Okay, so here's the sky and here's the water. As the distance happens, here's what's happening. Okay, I'm overlapping, but not perfectly, so you can see. Each one of these is losing to the other, okay? One is swallowing the other, but they're both equally going away. Pretty close. And so the bottoms of the buildings get cut off and the top of the land or water gets cut off. So the sky's getting cut off and the water's getting cut off, or the land's getting cut off equally. They're converging, okay? They're not just meeting and then staying there. They're literally swallowing each other up, okay? And the farther you go away, the more they swallow until, miles of sky and land are being converged together, and one is literally cutting the other off. That's my explanation. If I'm wrong, somebody show me where I'm wrong, because observation dictates that we know that those building bottoms are still over there, and they're not over the curvature of the Earth. They're below the line of convergence. That's all. They're just below it. And so the other thing, and then I'm going to go to Lawrence because he's been also looking into some of this too. Refraction. Okay. Refraction is explained as the bending of light. Okay. When you talk about the word bend light, it's bending itself. It's in bends, right? It's in waves. Light is waves, and different temperatures create different wavelengths of light. So if you have a hot concrete and cooler air above that, that's where you get that whole miragey refraction, wavy lines of heat. It looks like heat over the concrete, because you have two temperatures fighting each other. So the light is refracting differently at different speeds. That's about all the word you could use is speeds. And so, yes.
It creates a lot of white noise, in effect. I mean, of light,
yes.
Right. Essentially it's all interference of different, it's like putting a whole bunch of different radios on, and different stations. And eventually you're going to just hear a cacophony of like like, you know, like a subway train going by.
Right. So like with the red boat video, the bottom of the boat was not over the curvature of the earth. Okay. It didn't, the boat didn't go down. The top of the boat, and here's how I can prove it. The top of the boat stays as high above the water. Okay. The bottom disappears from the bottom up, not the whole, it's not sinking down below curvature. And so the imagery in the middle there between the two different elements, water and air, are refracting the light to where when you're looking at it, your brain can't determine what that is because of all these different wavelengths fighting each other in refraction. Okay, so you've got refraction and in this case reflection, mirroring going on combined. And so for people to just automatically throw that out there that it's going over the curve and the bottom disappears first, well, of course it does, but just as much as the bottom is disappearing, the top of the water is also disappearing. So the two lines are getting consumed by each other. And so, yeah, I'm okay with, people saying there is no curvature of the earth and that, but these experiments, and this is kind of where I want Lawrence to take off, these experiments for measuring curvature, why are they moot, Lawrence? Why don't they matter? And why won't they ever matter? Why are we wasting our time with that?
Because, for example, if you look at the palms of my hands, and you look at your palms and look at yours, John, you're not going to find any hairs. In fact, nobody in the world, I've never known a...
Hope not.
With
no hairy palms.
With hairs on the palms of my hands. And if I suggested to you that we should start conducting experiments to prove there were no hairs on palms of our hands, you would say, that's a crazy idea, Lawrence, because everybody knows. And if you take a look at a sphere, you take a look at a globe, and look at the country where you reside, and then just imagine that you were miniaturized and you were stood on the globe where the country where you are is, and then you look down at your feet and the angle of your feet to the ground, it is not going to be level. It is going to be inclined. So the whole curvature thing is a red herring. If we were on a globe, it would be patently obvious that we were on a globe. You wouldn't see the curvature, but you would see huge falls away going one way and going up and going down the other way, unless you happen to be at the so-called North Pole. All the curvature stuff is a red herring.
Okay, so what you're saying is, why would we do experiments to see if anybody has hair growing on the palms of their hands when we already know nobody has hair growing on the palms of their hands? Why are we doing experiments looking for missing curvature when there isn't any curvature and there wouldn't be any curvature to discover, because you would already notice that you're hanging on for dear life if you were standing at the equator because of drop in elevation on a ball versus obvious, seeable, observable curvature.
Yeah, and we're still getting people posting videos about, they've done they've gone to the coast and they've looked across the bay and said they can see this, and it would be this way if it was flat and this way if it was a sphere. Well, it's just a complete waste of time because you're not proving anything. You're not advancing flat Earth anywhere. But what they're not saying is, look, this is where I am on the globe if it existed. If I was here on the globe, if you were on the globe at 30 degrees north, Laurie, or wherever you are, you're not far, you're about 27 north, then the angle beneath your feet, the land would be at an angle of 90 degrees less 27. You would have an angle of 63 degrees, which is extremely steep, and you couldn't go anywhere without, specialist equipment. You couldn't drive your car. Any car that you have, you'd be in first gear all the time. And if you were heading south...
And we'd all have to have Frank Lloyd Wright designing our homes with cliff-hanging dwellings.
You just turn the key in your car and you just drive down. You wouldn't need any gas.
No.
all journeys south would be free because it's downhill all the way, but it isn't. And every coastline that you ever go to and you look out, it's all perfectly flat. There's
Well,
no
but
need
here's the problem, Lawrence, and you know, we're already so indoctrinated with this curvature thing and with this measuring curvature and spherical curvature and you know, horizon lines and all this stuff. And yet, if you bring up what you just said, that if we in fact lived on a globe, the elevation drop down the side of the globe, the farther you lived south of north to the equator, everybody below the equator would basically be hanging on by claws. But when you bring that up, that's when everybody starts making fun and says, oh, that's crazy. We're never going to sell that idea. You know, why don't you just stick to curvature? Well, it's kind of the same thing, isn't it, Lawrence? Why didn't we just stick to the AE map like good little flat earthers and leave it alone? So we're discussing why you don't see curvature, because there isn't any to see, but you wouldn't see it anyway. I mean, I've had people, I don't know if you remember, didn't we have this argument? If there were curvature, would you see it? Because we've never seen any. How would you know what you're comparing to if you've never seen something, right?
Yeah, I mean, on all the curvature experiments they do, they assume that everywhere is up, but on a globe, everywhere is not up. You know, so the flat earthers are conforming to globe Earth rules when they discuss this. They are buying into the fact that everywhere would be up on a globe. Well, everywhere isn't up. You know, if you take a globe and you look at a globe, the top is up and the bottom is down and the sides are at 90 degrees.
Well, you have to decide on an arbitrary. You cannot have an arbitrary up. You have to say, where is up? Okay. Where's the top of the ball? And of course, most people say, well, that would be the North Pole with an angle and the da-da-da and the declination and the yada yada. Okay. But so if you said, okay, on this globe that we're supposed to live on, up is north, period. Right?
Yeah, so the whole thing is totally farcical and it's wasting people's time. That's the main thing. And because you've even got, you know, people who you know are in the same camp as us, like people like Darren Nesbitt, and he's off going doing experiments with poles and flags and measuring them out to prove that there is no curvature. But Darren, you're wasting your time, mate. You know, it's patently obvious there isn't any curvature because the Earth is flat. And if we were on a globe, then you know, you'd be looking downhill or looking uphill. It's as simple as that. It's a complete non-subject, you know.
It's a non-starter. It's a red herring.
The energy needs to be channeled into figuring out where we are and you know, other than on the level, the plane that we're on, what's above and what's below. Now, I was looking into this the other day just because nobody seems to discuss it at all, apart from, you know, briefly touching on it. But beneath the Earth, you know, and they say you can only go down 8 miles, and then it gets too hot so that if you were drilling, the drill bits don't work. Whether that's true or not, I don't know. Whether the Cola Deep, mine, whether that's true. I'm assuming that it's true. I can't see any good reason why they would lie about that. So we know that beneath the Earth's surface, it is permanently hot. There is a source of heat coming from somewhere. Now, how old the Earth is, well, you know, I would say it was a few thousand years old. You know, conventional science will say it's millions or billions of years old. But even if it was only a few thousand years old, the heat would have dissipated by now, because you've got if it was on a sphere or anything, and it's covered mostly in water, the water would have cooled it all down. If I was cooking, you know, something on my stove and poured water all over it, it would quickly get cold and the water would seep into it and cool it off. But there is a permanent heat source, or a heat source that is self-regenerating beneath our feet, that has been going on since the Earth has been here. So where is that heat coming from? Now, somebody posted a video the other day. I think it was Flat Earth Arsehole, and I don't normally watch his stuff because
John puts his face on.
Arsehole, you're not exactly you know, being serious about the subject. But he posted something that I'd already thought about and touched on briefly, that, you know, an alternative to Pac-Man could be two suns that, when one sun is going beneath the Earth while the other is at the top, when one gets right over to the west, the other is just popping up at the east. So they're in perfect, symmetrical movements. One's going across one way, one's going across the other. And the one that's going beneath is providing heat as the main heat source, because the little tiny sun in the sky does not provide enough heat to warm something that's 200 million square miles when it's only 30 miles in diameter, as it's alleged.
Okay. All right. I hear what you're saying, and
what is it? What is that heat source? Well, where's that heat coming from?
I'm not going to say I know, because I don't know, and I'm not going to say that there aren't two suns and that one's going under while the other's going over, or whatever. But that just why? I mean, that's like supernatural. That's like it's a little too close to the whole lava pump thing that Sargent used to talk about. I don't know, but I can't relate to it yet. Okay.
Right.
I'll listen. I have an open mind and I'll listen, but I can't relate to it.
Okay. The Earth was created. We know it didn't result as a result of a big bang, and it just miraculously formed into what we have now, with all these life forms and beautiful species and birds and trees and plants and insects and everything else. So it was created. Now, whoever created it, they have put some barriers there, so that you can only go down so far. In the oceans, you can only go down so far. That guy who went down in his submarine saying that he was super sailing or something, and the submarine wouldn't go. There was an ocean beneath the ocean, which is like the waters beneath the waters, and we know that we can't access the space above the Earth. So whoever's created it, they have put barriers in place. Whether the barriers are 100% and there are exit points, we don't know, but there are certainly barriers to stop an exit.
Well, let me just add to that. There are barriers that humans have been designed to be unable to cross. We cannot handle extremes. We cannot handle extreme cold or extreme hot. We cannot handle extreme air pressure by going too high without some kind of pressurized suit or something. Okay. We can't handle too much speed, centrifugal force. There's all kinds of natural elements that prevent us from going in any of these directions, when you really think about it, without some serious technology.
All right.
What do you think about it, John? Let John talk. I saw some eye rolls a couple of times, so I can't help but want to hear what you have to say, John.
Oh yeah, no. Interesting news. The Japanese scientists use giant undersea drill to reach Earth's mantle. It's a story on RT. Can't see that. They plan to drill to reach the molten rock located 6 kilometers or 3.7 miles beneath the planet's surface. Quote, they said, if we dig into the mantle, we will know the whole Earth history. I don't know about that. That's our motivation to search. Well, it's a good motivation. Researcher Mitsue Abe, who is involved in the project. Oh, he told CNN. Okay, well, we'll consider all points of the story. But it's headed by Japan's Agency for Marine Earth Science and Technology, or JAMS Tech. And it's going to take a few years to get it going. I think by 2030. They hope to start digging before 2030, so we got a while.
Yeah, well, okay. So I'm going to put that in the same category as the Chinese landed on the moon, and sent back pictures, and we landed on Mars and sent back pictures. Not humans, but machines.
I do have to refute something Lawrence said. It's something I learned when I was camping in Boy Scouts. If you have a fire and you take a paper cup, it doesn't have to be a wax paper cup. You could take some paper, regular sheet of paper, A4, I think you call it over there, or A1, and fold it into a cup. Pour some water into it, place it into the fire. Whatever portion of paper cup is not touching the paper, it will not burn. It will not burn at all. You can leave it in the fire, which is kind of amazing because it creates a membrane between the extreme heat and the water. So the water will eventually boil off in time, and if you have some paper above the water's surface, that'll probably burn off. But all the water will stay firmly in the paper cup in the fire, direct fire, mind you. Put it right on the coals if you like, and you'll just boil some water.
Okay, so let me just make sure, because I think you said the paper won't burn, but what you meant is the paper next to the water.
The paper
directly next to the water.
Right. Any paper above the water's surface in the cup of the cup, that'll burn off, obviously, because there's no moisture that's creating a barrier. So yeah, but it will boil off though.
So
No,
okay, go ahead, Lawrence.
Come on, I've raised the question about heat. So there may be lots of explanations, but that's the only one that comes to mind to me, is that there is a second sun that passes beneath the Earth that creates heat from below and causes. So if you go to, and I've been there myself, if you go to Lanzarote, you can go and have a barbecue, which is cooked from the hot rocks beneath the Earth.
Right, on the volcano.
Go to,
okay, all right. So let me just postulate a little bit about what you're saying, okay? Because the premise that you're using is that the sun is a physical object with physical heat, and that this second sun, which is the first sun when it's not above us, okay, or perhaps a new one is born every day. I have no idea.
Not physical
heat. What
heat.
you're saying is that the sun.
Laurie, question, seriously. You know, you've got lights in your house, haven't you?
Yeah.
And you've got a fire to keep you warm. But the power station that supplies the power to do that isn't hot, is it? It's probably cold. So the sun itself, I don't think the sun is hot. I just think the sun sends out light, and the light converges into heat when it hits them. So it's a cold object. So the second sun could be theoretically passing under the Earth, giving off the same light, and when the light hits the underside of the Earth, it generates the heat, which heats up the rocks in Lanzarote, so you can have a barbecue for the next 5,000 years.
Okay, well, let me just throw this out there. It's along the same line, but not really along the same line. Okay, so if the flat surface of the Earth is only, because I'm getting this picture of that disk flying through space with the dirt hanging out of the bottom and the water falling off the edge when you say under the Earth. Okay, either that or there's another upside down level there where that sun's going through and it's heating this lava or something. Now, the reason why I'm bringing this up is I don't watch that many movies, but when I, get in the mood to watch something lighthearted, it's hard to find something like that anymore. So I watched BFG. It's Steven Spielberg Disney collaboration called Big Friendly Giant, BFG, and it takes place in the UK, I think London actually, and the surrounding. And this it's an animated film. This 24-foot giant and this little girl who is an orphan and blah blah. So he picks her up out of the orphanage one night and takes her to Giant Land. When they're on their way to the reason why I'm telling you this is because I pay special attention to the big boy film industry like Steven Spielberg, and because I believe that they like to throw their little tidbits out there for those of us who are capable of sort of picking up on them, otherwise known as conspiracy theorists. And so when they're on their way to Giant Land, they jump into this water, and when they jump into the water, they're on the underside of a mirrored surface. So in other words, here's the people on this land, and when they jump into the water, now they're on this land, down and here's up, okay? And it's another realm, okay? And so it screamed at me, portal, water barrier, firmament, what's the next layer, blah, blah, okay? You did bring up that there's this density of layer of water below the ocean that man can't penetrate because it's so dense saline. And I believe that there's a density difference in the waters above. So when you say below, that screams layers to me. Okay. And by looking at this movie where they just describe in perfection going through a portal and being in reverse on the other side, which reminds me of the Tesseract cube and the layers of dimensions.
Well, that's an interesting point. Let's imagine that we're on a plane. Okay, so that's supposed to be horizontal. So we're in a plane, we're living on a plane, and it's all perfectly flat, obviously a few bumps for the mountains and things. And beneath us, there is another realm, okay, and they've got a sun just like ours, but their sun, when their sun goes up round that way, and ours go, if you imagine two suns going round in perfect synchronicity, their sun heats the underside of our Earth, and then our sun comes round and does the same and heats the downside of their Earth. It's like sunsets, isn't it? You've got a sunset, John's got a sunset, and I've got a sunset, but they're all different sunsets. So there are lots of different sunsets on this plane, but once the sun has got beyond outside the realm, to the far west, then maybe the sun does set and go down just as the other one is coming up. So as it goes down there, it obviously becomes nightfall there, and the one on the other side starts coming up and lighting up that side of the realm. But let's go back to the heat. You and John, give me whatever comes into your mind. What is causing the heat beneath the surface of the Earth? What thoughts do you have?
Well, the best one I had, and the one that resonated with me the most so far, was the no forest on flat Earth led me to the understanding of these giant piles of dirt and debris that possibly was the leftover remains of a giant fire that happened before. And the fact that if there were, I say the fact that and if in the same sentence, if there were these giant trees that had these giant root systems, they could continue to burn for a very long time. And the reason we have no idea how old the Earth is, which is why they say billions and billions, is because, it's been destroyed. It's been flooded. We don't even know what number we're on. It's kind of like, I'll take how many times has Earth been remade for, $1,000, Alex, that's where I have no way of knowing, with so much hidden information and so much destroyed past history and rewritten history. We don't really have any way of knowing, but I'm open to the two suns and maybe a sun for each realm and so on and so on. But I also think that what if the realm below us is hell, for whatever else kind of word you want to use? Okay. Eternal lake of fire. What if it really is down there? Yeah.
Well, the perception is
John's devil horning me.
Lawrence, I was listening to you, and I'm sorry, I gotta get this out. You talk about the heat, the molten rock that's underneath the mantle, or the first layer of whatever they propose is. I know, isn't that funny? Like, it's hot, it's molten, it's like the devil. It's like you're gonna burn in hell. Ooh, they're trying to scare you. Maybe there's not. It could just be pockets of molten, just like we have pockets of water in ocean basins. But it made me think about something, Lawrence. Is that the only time we see this molten magma is when it comes out of the volcanoes. We have one in Iceland. It's a kind of mountainous region. They have some volcanoes. There's Hawaii, obviously. They're underwater volcanoes. They may be bigger or smaller. They're more like vents, really. They might have something to do with the density of stuff. But we see nothing of this in the mountains, in the Alps, in the Andes. We see no evidence of any There's one volcano in, I think, the Atacama Desert, and it's like 14,000 feet, I think, or 18,000. I'm not sure. You got to check the Top Gear episode. But but really, the Alps, there's no volcano there, and yet that's the largest, structure. The Himalayas, there's no volcanic activity up there. Is that responsible of it? We say that's what builds it, but something is pushing that? Or is it just a big pocket of rock and some, water here and some magma here, and the rocks are sort of like stuck between the levels, and then maybe there's another level underneath it? That's a little presumptive in my mind. I'm open. I don't know if anyone's heard of the Sharafaland map, which is kind of weird. You probably won't find it online if you don't know how to spell it. But it's a weird map that doesn't make sense, and it's kooky. But it begs a question of not necessarily center of the Earth, but the other side or some other side. I don't know. That's all just presumptive stuff. I think if you can get to the heat, does it have anything to do with the sun? Does it have anything to do with cycles overhead? The radiation? The water seems to, I don't know, it's salt water, so it must take the radiation and do something with it as well. We have the ocean currents. I don't know how they're changing a little now. The south is coming into the north. The sun, though, like you said, from a quantum standpoint, I don't think it's responsible necessarily for the heat. I think it's just the light, and whatever the light comes into contact heats up, and you have, let's say, chain reaction of effects. That's radiation. It's probably not even there. It's just something that's projecting something. But I'm open to a lot of ideas.
There you go. You go. Okay. So if you try to combine all of the what ifs, okay, what if it's this and what if it's that and what if this does this, and you start to try to mold things into a hypothesis you're already working on, and I have a problem trying to do that, okay? Because I have already made kind of a pretty clear picture in my mind of the sun as a focal point of a greater light, and that it is not a physical object. It's not a burning, flaming, because see, that's kind of the part that kind of set me back up when you started talking about magma and the sun, is that I don't think the sun is this nuclear fission, burning, molten, fiery object like they show us, in the science world, in the astro science world. I don't think it's like that kind of a physical object. I think it's a manifestation of a directed focus of light coming through from wherever it's the greater light is coming from. Just like if you had a magnifying glass and you were holding it over the ant on the concrete, a little some bitch is going to get hot, right? If you focus that light, that pinpoint of light on that ant, you're going to burn him up. Now, does one have anything to do with the other? I think it's a red herring.
And there's no spotlight of the sun, is there?
No.
It's all just diffused light.
Yes.
So,
right.
I mean,
it's
see
not
from
a flashlight.
Yeah. I mean, that you would know that from the NASA composite animations, but yeah. Well, even if you take a laser, take a red laser, take a green laser, and shine it on a white wall, like a wall in your house. So it's not like a completely smooth surface. You're going to notice there's a bright beam in the center, and then you have a diffusion that extends for a certain radius, depending on how far away you are, how powerful your laser is. And that's, it's just diffused light. We don't even see that kind of thing. There's no spotlight or nothing.
Right.
People might argue, oh, well, that's what the deserts, that's why. But that doesn't add up, because you have Australia.
No, right. We already went through. They're
right,
not
exactly.
They're not all in the same place.
It's a dead issue.
Right.
Yeah, right.
But now let's think about this. If the light of the sun were a flashlight, okay, think about the physical flashlight would have to, when it's overhead, when it's over my head, okay, it's shining straight down on me. When it's over Lawrence's head in the UK, that would put it at an angle to Lawrence at the time of day that it is, but when it's overhead of him, it's straight overhead. So what is this? This flashlight is going like this all day long too, it's going over and then it's turning and then it's, no, I can't see that. But what I can see is, for example, people have been posting all of these photos or videos of the light shining on the undersides of the sunlight shining on the undersides of clouds at sunset. I don't have a problem with that. The sun is far enough away that the angle and the refraction and the reflection off the land and the water would throw the light underneath the clouds, okay? Because you can stand there. I mean, I live in Florida. We have some pretty magnificent sunsets. And I live pretty darn close to the Gulf of Mexico. So when I see the sun setting and I stand directly east of it, which is pretty much right in front of my house, looking at it, I can see, all the colors and the orange and the change and the purple and the light bouncing on the undersided clouds and so on. And it's brilliant. And then I can all I have to do is turn my head and look that way. And it's twilight looking over there already. Okay. There's no light, not much light over there. And the light over here is pretty tight to a circle. I mean, there's not that much diffusion out from it when I look north and south of that sunset. And so the flashlight thing falls down. The burning, flaming ball of fire falls down.
There's one other thing. There's one other thing. When you're looking at that sunset, generally it might be a little like red or orangish, in that part of the sky where the sun is, going down. But if you take a look at the other part of the sky, overhead to the north, to the south, to the east, you'll notice, a dark bluish sky, and it continues to get darker incrementally. But look at the horizon. It's completely like a whitish band from north to south, on the opposite side of the sunset, which is kind of fascinating because you have still, as the sun's going down on your perceivable horizon, you have that interference pattern of whatever we want to call the light, and yet the sky is still blue.
Right. And so that's where I say, you can call it biblical if you want, but it is where I first read it, and it has never left my mind. The first thing God did in Genesis 3 was create light, and it was good. And in Genesis 1:6, he created the sun, the moon, and the stars. Now, okay, that's biblical. But if you take it apart out of that context, and then you look at the daylight and the night light, you can see that there is more light than just what the sun is making. That is the peripheral light, the residual light left as the sun moves away. Okay. And if you are fortunate enough to be in a place where there is little to no light pollution, which is pretty much nowhere now, then you can watch this transition. Of course, now if some Globers listening, they're going to go, well, duh, it's because it's going over the curvature of the Earth. And that's why you get that residual light. Oh, God. Sometimes. These are the kinds of things that, if you start out being a globe skeptic and you move into being a flat earther, there's a reason why you move to flat Earth. People say to me all the time, you seem like a pretty intelligent person. What's with this flat? I mean, you don't really believe that, do you? Is it because, your teacher beat some kind of sense into or science into you when you were little and you rebelled? And no, I'm going by what I observe. And once I start to question, I can't stop questioning everything. Just like this line, I set out to do a curvature study myself when I did the red boat experiment. Okay. The red boat video. I was there thinking, ooh, I'm a pretty new flat earther. I'm going to get a curvature experiment under my belt, and I'm going to show that this boat, I could see it this X many miles, and it should be below the curvature of the Earth. But what I ended up with was, a lesson to me not about curvature, but about the line of convergence, refraction, reflection, what you said, white noise, so on and so on. So, Lawrence, I want you to tell me why this two sun thing resonated with you, because you and I have been doing this long enough that you don't just go off on a lark.
I'm not saying that's what it is. I'm just, looking at different ideas and seeing whether it, something develops. But
okay.
Let me ask you another question. So, I mean, every time you go to the seaside, we call it the seaside in the UK, the coast. Okay. Every time you go to it's usually when you get to the edge of the sea, there's always a load of sand there, isn't there? Why is there always sand at the beach? Now, I was walking down the beach the other day. And I'm
sorry. Okay, hold on.
I was walking down the beach.
Okay. We're zipping over here to a whole nother topic about sand on the beach, but I'm sticking. I'm with you. Go ahead.
Yeah. So I was walking down the beach and I was talking to my other half and saying, where do you reckon all this sand comes from? I mean, as we were walking along, there was a load of shells, and sometimes you get loads of these shells and you walk over them, they scrunch, and there was all these shells in different sorts of gradation. They've been scrunched up more. And I was thinking, well, maybe that, when they get scrunched up so much, they become sand. They're made of the same stuff. It's all, silicon, isn't it? Shells are made out of silicon and sand's made out. But all that's, every time you go to the coast, there is always sand. And we've got deserts, I think the Sahara Desert's bigger than the United States. I think I read that the other day. And you've got all that sand, and you think, well, where did it all come from? Where did all that sand come from? Where did it come from? Where does the sand
You're asking me where sand came from?
On the plane.
Because there's a whole bunch of different kind of sand. There's places where there's this beautiful black sand, like in Hawaii. It's black sand. John, I think
Black
you should
Lava
go first.
Beach. No, I really want to. I've heard about the Black Lava beaches. I want to check it out.
This question.
Oh boy, sand. Sand comes out of my eyes every day. Horrible.
The Sandman.
Oh no, but it's a different. Like you said, it's a different kind of sand, because you can't make concrete with the sand from the Sahara.
Well,
why can't you?
Because it's too fine. It's I don't know. They say it's like from wind erosion, maybe. I don't know.
Last time I went on my holidays, because I usually go to the Canaries because it's not expensive to get there, and it's not expensive when you get there. But when you drive between the different places, if you sightsee and you go on a bus or you hire a car, when you're driving along, it's as though somebody has scraped all the topsoil off the land, and it's just all rock and a few bit of tumbleweed, like the American desert. It's blowing across, and there's been a big famine. And when you go there, all the water that's on there, it's all bottled water, and the water that comes out of the taps is from a desalination plant. Without that, the place would be just a desert. But that's off the coast of Africa. If you went 25 miles off towards Africa, you'd hit the Sahara. So the question is, this is going back to the spin-off of no forests on flat Earth. Was the Earth scraped away at some point in the past? And a byproduct of that was all this bloody sand, because there's all the golf courses in Britain, they're all along the coast, most of them, and they're all some huge big sand dunes, and it goes on for miles and miles. Well, how did it get here? You go in the middle of the country and there isn't any sand, it's just soil. You got the black, thick, rich soil. But on the edges of the landmasses, you've always got sand, which doesn't make sense to me, because landmasses.
Well, you know what, Lawrence, just while you were talking there, okay, I Googled, where does sand come from? Just to see what popped up, okay? The top response is, sand is made from tiny grains of rocks and minerals. It can also be tiny particles of the shells of sea creatures. Some sand comes from the calcium, a mineral in seaweed. Sand can be different colors. Then it goes on. There's the next one that says the origin of this famous coloration is the remains of tiny single-celled creatures called foraminifera that have pink or reddish shells. Hawaii, meanwhile, is well known for its black sand beaches, and that's supposed to be ground up dark volcanic rocks. You know what I think? I mean, one place I just read there says it's fish poop, ground up fish poop makes sand. Okay, that's what you're walking on. So I think that, kind of go back to those giant trees thing, okay? And it's not just about the trees. It's about possibly there having been a silicon-based flora and fauna Earth prior to this one. And, you were talking about the roots and the rocks and so on. Different sand comes from different places. What if all of the sand, some of the sand is ground up sea creature shells, but you're talking about a lot, okay? Like a lot. What if it's the powdered ground up roots of silicon trees and animals, or trees and plant life that came before? I mean, what if there was a great big tree where this, or forest where the Sahara Desert used to be, and the top of once the flood, and what we're told stuff is not necessarily.
Do you remember the movie Evolution?
Going to believe.
Have you ever seen the movie Evolution?
Mm-hmm.
Yeah, and they talk about how to kill the alien race, and they're like, oh, well, we're carbon, and if you go down, you find arsenic, and they're right below us, silicon, and if you go there, and you're like, if you look at the periodic table, silicon is right underneath carbon.
Mm-hmm.
So I don't know if one came before the other, or I'm not sure. I mean, that's carbon's on top, so I don't know how that might jibe in like an evolutionary sense, because we're sort of carbon-based life forms. And if you have silicon, is it something before or something that's coming?
Well, and
AI.
maybe it's been there, done that, coming back. Who knows?
Can I just go off at a tangent again, because
sure, why not? This seems to be your night, Lawrence.
When you have thoughts in your head, sometimes they lead to interesting places.
I know, and I want to hear them because sometimes they're pretty good.
Well, when I was quite young, yeah. I mean, you remember this thing on the news about the Chicago skyline? The guy said, it's a mirage. If you're more familiar with that. But when I was a kid, I thought a mirage was something that was in your imagination, and it wasn't something to do with atmospheric conditions. So if you look at the definition of a mirage, it says an optical illusion caused by atmospheric conditions, especially the appearance of a sheet of water in a desert or on a hot road, caused by the refraction of light from the sky by heated air. But another definition of a mirage is an unrealistic hope or wish that cannot be achieved. So why is the two definitions of the same word?
Well, and there you go. Okay.
Who made the words?
Who made the word, and who defined the words, and look, in my lifetime, the meaning of words have changed. The term anarchy, okay, means no rules. No rulers. It doesn't mean no rules.
When he was 15,
so they baked in the words, Lawrence, and so if they need to make you think that a mirage is some figment of your imagination, then obviously, if you saw a mirage, if you're out in the desert, you're thirsty, you've been walking for days with no water, and you see this glimmer, then you probably would like, oh, I got to crawl to that. I need water. And then it's not there the closer you, and the farther you crawl, the farther away it gets, because it takes a certain distance for it to show.
That mirage is a terrible mistress. Oh. Yeah.
So if you're delirious at that point, then you probably would think you see an oasis of water. Just even the word oasis, it has multiple meanings. Look that up.
Osiris.
Yeah, because I used to do a lot of driving late at night when I was a broker, and I used to go around organising finance for people. And I used to get pretty tired at night. It was hard work staying awake. And I think once you get your awareness level starts to fall off a little bit, you're entering another realm of sorts, because I'd be driving along and you'd have a big row of trees that you're driving through. What's a row of trees called? I don't know the word for it. A grove of trees, and you're driving through, and these trees, I'm totally sober, not under the influence of any drugs or anything. These trees, late at night, they would suddenly form shapes of things and creatures and all sorts of things. And you're thinking, well, why is that? I don't see it in the day, but when I'm tired, and my level of consciousness and awareness is lower, I am actually seeing something different.
You just talked about another thing that was in that BFG movie. The giant lurks around the town at night. His job is catching dreams and taking the dreams and giving them to people with this little horn thing that he uses. But as he's sneaking around the town, he, if somebody walks around the corner or comes out the door or whatever, he takes his little cloak and he forms himself in the shape of a tree or whatever. And so, there's all sorts of mental mysteries that are occurring to us all the time through our lives. And it's one of the reasons why we question someone else's explanation for how something works. And one person can consider an event that happens as miraculous, supernatural. Another person just says, "Oh, what an amazing set of coincidences that all happened for that to all turn out that way," right? So it's all based on your own history, experience, perception, background, knowledge, religion, mythology you've heard, so on. So, this leads me to the two words, natural and supernatural. What is natural and what are the boundaries of natural, and where does the boundary from natural turn into supernatural? Is something supernatural because we can't explain it using our typical known sciences, there's a lot of them now, okay? Everything from astrophysics to microphysics, all that, and dielectric, blah, blah stuff, okay? Somebody's always got what sounds like a scientific answer for a possible supernatural occurrence. And I'm one of those people, I'm completely okay with something being supernatural. What does that mean to me? In my opinion, if it does not fit into the laws of nature that we know of, then I consider it a possible supernatural explanation. So it's why I had no problem with Pac-Man.
Yeah, it's funny.
No problem whatsoever, because it's just supernatural. It's outside the laws of nature.
Can supernatural equal artificial? And if it's being artificial, does that negate its supernaturalness?
Well, I don't automatically equate supernatural with artificial.
Well, I'm just
myself. I guess it could be. Yes,
I'm just bringing it up because you bring the natural, the supernatural, and I'm just thinking of the any other possibility to the logic would be artificial. Now, artificial by who or by what, I don't know, but adding the possibility of artificial to the equation and how that goes in those rings.
Okay, well, so in my opinion, then supernatural, by my definition, is not explained by any of the laws or theories mankind has come up with. It breaks the boundary of explanation for, and you've listened to some of these NASA scientist people and the arc energy of the hydro collaborator of it creates the refraction of the super, you've heard it. And it's like, what the hell is he even saying? And how would anybody know if he's wrong? I mean, he's just blast coming out with all these words. And, it's like, I'd have to stop to define most of them before I could even question the guy. Right. So what I mean by, what supernatural is to me is unexplained by the laws of nature. For example, you could take something like a tornado comes out of nowhere. I mean, it seems like a fairly nice day. You live in Kansas and all of a sudden, boom, there's a tornado. And people go, wow, there was no reason, no pre-knowledge of this low and this high and this air pressure and this moisture and this whatever that creates tornadoes, as if anybody really could. To me, if you can understand how they are created, you could create one, but man can't create a tornado. Do you see what I'm saying? That's supernatural.
Oh, well, then again, Lori, I agree with what you're saying, and I would refute you by, calling into question the idea of HARP and geoengineering, and well, they can call
okay, they're trying. No,
and I'm not trying. And I'm not trying. And I'm not trying to take you down with that, but
No,
I'm saying
okay,
I love coming up with other phrases, and you have natural, you have supernatural. I just mentioned artificial. How about extra natural? We have the extra sensory perception that we have our normal ability, yet there's some people that can exhibit or can touch this extra sensory, realm, whatever you want to call it. Well, then maybe there's extra natural. Like, we don't know why these tornadoes happen, but maybe it was like 500 people in Oklahoma were thinking there was going to be a tornado, and
they manifested it. Okay.
And I tread lightly.
No argument. No argument. And you can tread lightly or
I don't want to disrupt the
harshly.
quantum gods. Be
No,
careful.
I know. Well, okay. But I definitely think mankind loves messing with the boundaries of natural. I also think mankind, especially, agencies like DARPA, for example, who are constantly testing the boundaries of everything and trying to create and cross connect and so on. Scary stuff, some of them. But if man can't, if man can't create it or control it, okay, to me, that's natural.
When can man control anything? You can't control your kids. You can't control your pets.
But you understand what I'm saying? Man can't control. We play with trying to make it rain, trying to make it snow, trying to move a hurricane from over here to over there, or redirect one to a different place and create clouds.
You keep talking about man creating something, and the last time I checked, there was a woman that could only create another man, which is kind of funny.
Okay, well,
I'd just like to add that.
And I'll accept that also. But what I'm, when you talk about creation, you have to make something out of something else, or make it out of nothing. Okay,
or destroy
Making something out of nothing is supernatural.
Yeah.
Okay, I can't make something out of absolutely nothing, but I can take some things and I can create something with them that it did not previously exist. That's the level of human creation that I'm talking about. The rest of this stuff, okay, quantum physics and quantum mathematics and all that stuff, where somebody says they can explain something using mathematics, okay, and therefore it exists, that's where I start to break down and go, that's numbers that say something exists. That is artificial. That's back where you go, where you came in with artificial. Can you create something with numbers?
Well, I mean, numbers help, numbers are...
No, can you actually make one of those giant freaking chalkboard, formulas and create something with it?
I guess an app, if you want to look at, the social network movie on a window.
A physical thing. Can you create a physical thing from numbers, from nothing?
That's
I think
kind of semantical. I kind of think got me.
Good.
I mean, they're communicating now, and basically the communication is numbers traveling through space from here to the United States, and then reconfiguring themselves as sound and words when it gets there. So that is something. It's not a solid object, but it is something that's tangible.
Well, sound can do things to other things. It can affect other things. I mean, it can, certain sounds can knock a building down. Certain sounds can break a glass. Certain sounds can, on and on. So what I'm saying here is, in a sense, I'm trying to define the defining line between accepted natural and supernatural. Supernatural to me is not only unexplained outside of, like I said, some big long equation that makes sense out of it, therefore it exists because I can make this formula that says it does, must, should, like black holes, for example, and quark things. And I totally sound like a ding dong when I start to use scientific language, because it just sounds like gobbledygook to me, because I don't care, and I just didn't ever go there. Okay,
that's the way it's supposed to sound to people like us that don't have PhDs.
Well, and the reason for that is so if that's that whole technocracy concept. I'm an expert, you're not. I know stuff, you don't, and therefore I'm superior to you, and I should make the rules, or I should guide the ship, or I need more eye vitamins, vitamin I, whatever. Okay. So that's why I just continue to use the word realm, okay? Because a realm, in a sense, is a supernatural explanation for what appears to be a natural world, okay? And yes, we visited into the simulation theory concept, and it came on like a house of fire all over everywhere in the flat earth and everything. And then as quickly as it came, it went. Didn't seem to really resonate with most flat earthers. Yeah, thanks.
Thank God.
Thank you, Supernatural One.
Oh my God.
And so in closing, Lawrence, I believe that you also have no problem with the concept of the supernatural, because you wouldn't be able to wrap your mind around Pac-Man. But for some reason, I feel like you're trying to make a natural explanation for what could be a supernatural part of the realm, the magma thing, the volcano magma hot below the earth surface thing.
Yeah, I was just putting it out there just to see what you thought about it. And I was watching this little documentary the other day, and funnily enough, when I was watching it, it was 1969 documentary made by the BBC, and Patrick Moore was talking to flat earthers in the United Kingdom. And funnily enough, there was talk of an ice wall as part of the flat earth model. But there was this guy who I found quite interesting. I'm just going to play a couple of minutes of it, and then we can have a little chat about it. There won't be any copyright because the people are all dead now. So just bear with me.
Well, that doesn't mean anything. Somebody probably bought the copyright. So
there are only 6 people that own all the entertainment. So
yeah, I know. Are you screen sharing, Lawrence?
Is my sound? Tell me if this sounds.
Probably not. No, I'm not hearing anything.
I did see the screen.
John Gregg of Ashton-under-Lyne.
Do you get it now?
All orthodox.
Yeah.
Yes.
Right. You got it.
Has constructed a picture of the universe that is all his own, based partly upon theory and partly upon observations made with his strictly unorthodox telescope.
What the hell is that? Oh, telescope.
Yeah, this looks like a conventional telescope, but I gather it is.
No, it's far from being a conventional telescope because it isn't split up in the lenses. Most of the lenses in this telescope are at the eye end.
Down here,
Yes, there's only one object at the other end.
what's the purpose of having so many lenses?
Well, you can't get the power without. You must have the power to bring the object very much closer. With a conventional telescope, you can't do that.
I would have thought that every time you passed a beam of light through an extra lens, you'd lose a bit of light.
Yes, that is so that you do lose. But looking at objects in the sky, you don't need to lose it.
Looking at your map of the Earth, it looks to me as if you've got the North Pole in the middle and all directions are south. Is this correct?
Yes, it is correct in that method.
What about gravity?
Sir Isaac Newton, when he was in an orchard in Lincolnshire, saw an apple fall from the tree, and he brought out his theory of gravity, that the gravity had drawn this apple to the ground. Yet, he didn't make a law which held the other apples on. Now, he also said that if you could stand a needle on its point without any support, he would believe that the world wasn't going round. Naturally, I had to bring out a new theory to prove the shape of the world, the shape of the Earth too.
Which is what you've done.
Yes, that is it. And you see, no matter where we are on the Earth's surface, we will always be pulled back to the centre.
And that's why you can't go to the edge of the Earth.
Yes, you cannot go to the edge.
Well, let's have a look at the actual diagram of the Earth itself, shall we? This, I think, is very interesting. I know that you've got the Earth with a flat top and kind of a round underneath. Is this correct?
Yes, that is quite so. You see, this is more like a jigsaw puzzle. You can't complete without a flat top Earth.
So this is the entire universe.
Yes, yes. You see, you've got the full metallic stony background, and this, of course, is where the flow of magnets on this.
What is this line down here?
Now, this line is for the sub-semi-vacuum that divides the pure vacuum from the semi-vacuum which surrounds the Earth itself.
What about the sun and the moon?
The moon
It's a flat disk, isn't it?
not actually flat. It is slightly convex, but not much on the surface. Now, it is a disk of carbon.
The moon's made of carbon.
Just carbon,
Yeah.
just a carbon disk, which shows in this.
Yeah.
This I saw 2 years ago on the harvest moon, September moon. And this material here is plasticine phosphorus, or a material very, very similar to.
But where does that come from? Where does the plasticine phosphorus actually picked up?
It's circulating in the atmosphere. When the moon's waning, it allows it to go on. When it's waxing, it picks it. Now, this illustration here is more of the moon itself, with a finger-like projection coming over the top. This happened in 1953, and the finger-like projection stayed on for 3 days.
Was there only one there, was there?
There was only one step. I built another telescope, and I used an astronomer's telescope too to prove whether I was right or not, but I couldn't see it with the astronomer's telescope.
And was this due to the plasticine phosphorus spreading over the moon gradually?
Yes, but I think it picked a little more up than it should have. The surface of the moon, the thickness of the surface is around about 1 inch. This has been really worked mathematically.
What incidentally about the sun? Do you think the sun is small also?
The sun would be, I should think, about twice the size of the moon, because the moon can go in the front of the sun and cover the old sun up, and that is why the sun really is only twice the distance of the moon.
And of course, the sun presumably is very much hotter than the moon.
Yes, we speak of hot as hot, but the sun actually is cold.
I
Very,
see.
very cold indeed, because we couldn't get a lot of heat. The sun wasn't cold.
Can you define light quite shortly?
Yes, we can work on that on.
I don't quite understand this caption down here, but all red light is green.
Well, we always knew that infrared light itself was red, but it isn't. It's actually green. You can easily prove that by plugging in electric fire. You get the green light, and then you get the red light, which of course are interchangeable. Green being the only colour, really, it makes up all of it.
So all light is in fact green,
It is
including green itself.
yes, including it, not red.
You know, I think you're going to be the first to admit that these ideas and theories of yours are not conventional ones.
Correct, yes.
Well, I know that you've also given lectures at various universities, and I wasn't at your lecture at Cambridge University or at Keele, and I heard about the people who were. And how do you find that other people react to your ideas?
Well, some people, of course, when it's all explained thoroughly, they will accept. If it isn't explained thoroughly, well, of course, they think we're nutcases or something.
Yeah. So anyway, so it's quite an interesting guy on that particular little documentary. It's worth watching anyway. So Sir Patrick Moore, One Pair of Eyes, Can You Speak Venusian, 1969. And in that documentary, you hear talk about the ice one stuff. So and he interviews a load of school kids asking them about gravity and stuff like that.
Well, he's dead on about infrared, because if you look through an infrared camera, it's green. There you go.
Right.
Yeah.
And I liked the part about the apple doesn't fall far from the tree. He came up with the theory of gravity, but he didn't, a law of gravity, or theory of gravity, but he didn't make a law that kept the other apples on the tree. I thought that was pretty good.
Yeah.
Very nice.
I pick up on weird things.
And the latest update on the jam, which is about 2 weeks now, is that none of them have got any mold on yet. I did check them today.
Oh, that's good. Well, that's interesting. The new jam experiment is one jar has hate words and the other jar has love words, and then there's a control jar that has no words. So 2 weeks, no mold, no response. And actually, if I remember correctly, that follows along pretty closely to the quinoa experiment. It took a few weeks for that one to kind of kick off too. So,
Lawrence, I got a question. Do you hide these jars in the dark, or do you keep them like exposed to normal sun or whatever normal would be?
Just in the normal light in the house.
Oh, okay.
So, John, how are you getting on with doing that? Those graphics on the directions changing. So, I thought we were hopefully going to get something showing the globe model where east-west, if you're in the northern hemisphere, then when you eventually get to the North Pole, east-west becomes a southerly direction, and in the southern hemisphere, east-west, once you get to the South Pole, becomes north, which sort of totally invalidates any possible navigation on a globe.
I'm totally in agreement with you, and it just basically working out, just creating lines over the map. It might be easily done on just a normal Mercator and then just transition to the diamond. But I honestly haven't had time to sit down at Photoshop and do it. But it's basically just overlaying one grid. And my thought is that that some sort of it's not going to be the normal magnetic grid. It's not. So I'm going to try to do some overlays with snatching whatever respectable source online has the lines of magnetic north and south over the Mercator map. Do that into the thing. Do that with the other northeast south lines as they gradate, through the latitudes. And then I don't know, perhaps overlay something with the UTM. But I mean that's really simple.
UTM. That's another one. So obviously, with the UTM map, Free Energy led us all to believe that it's a big square grid that covers all of the Earth.
Yeah.
When in fact, as you move away from the equator, each square has a smaller area, and as you get up to the poles, they have two separate maps for it. If you could do some graphics which showed the UTM as it's shown to us, and then you could factor in the smaller scales as you move away, we would get the diamond, but it would look fabulous if we could have it in some kind of graphic.
Isn't that how the sinusoidal map is laid out, with the diminishing lines of turn?
And I really don't want to deal with the sinusoidal again. I don't want to get back to Gore maps or anything.
Right.
I want to keep it diamond.
The idea really that Lawrence is trying.
I want to see the patterns. The patterns of three separate things, separate grids.
On the globe that we did, showing on Google Earth when Lawrence went east, and then you changed latitudes. What happened, and anybody can go back and look at that video. It's one of the last one or two that we did, where we snapped 90-degree and 270-degree lines on the Earth, on the Google Earth globe, and then showed what happened by trying to go 90 degrees. And of course, some people were very, globe apologetic about that. Globe apologists. There's, that whole apology thing is really starting to get on my nerves. I mean, there's just everything you tear into, there's an apologist out there with what they think is some really pat answer for why that's the way it is, or why that works, or what are you, stupid, or a moron always goes right on top of it. But or don't you even science, dude? No, dude, I don't. Not that kind of science. I don't do apologetic science. And the whole problem with the using the globe for navigation, which no one does actually, is you can't. There's not even little tiny or great big globes sitting in the cockpits of planes in case you get lost, or people don't drive around with globes in the car. Ship captains don't get out the globe. I think we're lost. I think we've gone off course, mate. Get out the globe and let's find where we are, and how we're going to chart a route to get where we were going. So there is no you are here on a globe to be able to go, okay, like you're at the mall, right? And you find a little globe of the mall, and you are here, and there's always a left or right turn, or go down this hallway or that hallway, north wing, south wing, west wing.
Well, I think Lawrence outlined it perfectly, when he talked about the heading route going from Alaska to England. And seriously, you look on it at a globe, and or if you do the heading on the Google Earth, which is the globe, it just doesn't work out, and you do it on the flat Earth map, or the flat Earth diamond map, and it goes straight across latitude wise.
Exactly.
So I mean, we've proven it from that regard, Lawrence. And now it's basically just like a spirograph. I mean, just basically connect the dots, show the matting. I don't know really. I really can't look ahead. I'm sort of in a haze about what I'm going to learn from it, though. That's the only thing. Because I'm like, okay, I can envision how the UTM would be, and it's basically just going to be parallelograms, getting larger or smaller, and you're going to take a look at the magnetic lines, the flux lines, and it's going to be, a little wiggly and out of control. And then we're going to take the heading lines, northeast, and we're going to see them, slowly, they're going to curve in slowly towards the equator. But as you get further, they're going to curve, further, but it's going to be a direct line. So, and I want to be careful not to do this from a real globe-centric perspective. So that's why I'm kind of taking my time on it, because I usually like to visualize things in my head a little bit before I start mapping them out, even in digital form. And this one's sort of a bugger, because it's going to be all different directions. So
one thing people need to understand is, let's see if I can, without it all glaring.
I can generally see it.
You see it? It's my little globe drawing I just did. Okay. This makes no sense why all the lines converge at the poles. The longitude lines converge at the poles. And yet there's no convergence point for the latitude lines. And why are they all straight cutting the globe into, straight sections? Because if you think about it, if all the lines converge, longitude lines converge at the poles, and I said this before, okay, that's just the longitude lines, right? Okay, then it seems like it would have made sense if they would have done the same thing. No, it's even hard to draw. Okay, there would be an east-west convergence point, right? Or like a pole. On it. So doesn't that make more sense for it to? It's a sphere. Why is the sphere broken up into longitude lines converging at the poles? Yet,
I get what you're saying. Why didn't?
Yeah.
Right. Yeah. Well, it's a sphere, so you can have multiple poles: the east pole and then west pole, or.
But why are the other lines all straight? The latitude lines. Why are they all straight? Because it's not a sphere. Yeah. because they were able to fake putting a flat coordinate system together. Okay, they did the latitude and longitude lines a really long time ago, right? Back in Queen of England day, or of course you still have one of those. Always forget that.
Oops.
King of Spain days or whatever. And so that should scream at people. Why'd they do it like that? Because that works out for the diamond, the lines of latitude going this way, right? The equator in the middle, completely horizontal, all the way from east to west, 90 to 270. Okay, that works. And so do all the latitude lines, because otherwise you should be able to take that sphere and turn it. People say that all the time. It's a sphere. There's no up, right? Well, the whole grid system is designed with an up and a down when you look at the latitude lines. 90 north, 90 south, right? 0 degrees is the equator. It's annoying. And yet, you say something and they'll say, well, why did they come up with the word equator if it wasn't a sphere? Because around the center it's the circumference. Then why didn't they call it the circumference? Why did they call it the equator?
And it's a bit like, just imagine that this lemon, I haven't got anything perfectly round, but it's nearly round. Okay, imagine this is a perfectly round piece of fruit. Okay, not egg-shaped. And then I tilted it. It would look exactly the same, wouldn't it? Doesn't matter where I tilted it.
If it was a ball, if it was round.
Yeah, it wouldn't look any different. So how did they know the Earth tilted? And what difference would it make? It wouldn't make any difference if the Earth tilted, would it? It would still be exactly the same shape.
Well, that tilted thing was devised. That's another one of those ad hoc reverse engineered theories to describe what otherwise is called the seasons, as to why the sun, which is the thing that's moving north and south between the tropics of Capricorn and Cancer, the tilt is what makes that work.
Isn't that a nonsense?
Otherwise, it would just be the same. The sun would just always be the same every day for everybody. If you live up here, you're shit out of luck. You're never going to get any good season if you live down here.
So if you look at, what does big science tell you about the tilt of the Earth? It doesn't tilt back and forth every year. It just allegedly tilted once in the past. So how would that create the seasons?
Well, because as it's supposed to rotate around the sun in 365 days.
It's not tilting now, though, is it? If it was
always, no, Lawrence, it's always supposed to be tilted at 23.4.
Well, if you tilted it, all it would mean is that the places in the middle would be a bit higher, and the places on the other side that were in the middle would be a bit lower. And you would just have a new equator to what it was, wouldn't you? You know,
I don't know. You lost me. All I had my head stuck on was the 365-day turnaround.
Create seasons. You still got a perfect sphere. So how does it create seasons?
Because sometimes during the year, the 23 is this way going, and then on the other time of the year, it's still this way. But now these guys, that's the story.
Yeah, but it would have been tilted before in exactly the same way. If it's a perfect sphere, what difference does it make? Doesn't make any difference. You wouldn't need a tilt.
Well,
why would you need a tilt if it's a perfect sphere?
Explain the seasons. That's why that's the idea. Okay.
Seasons.
It takes. Okay, I'm done. You're screaming over me. 365 days of the year it takes to go around, for the Earth to go all the way around the sun, right?
Yeah.
The tilt is the same all the time. So when the Earth is supposed to be over on this side of the sun, this face is getting less of the tilt, and when it's over on this side, this face is getting more of the tilt.
Yeah, but that would
the exposure to the sun on the surface of the spinning sphere.
That would be exactly the same whether it tilted or not, wouldn't it?
No, there would be no seasons, Lawrence, if there was no tilt.
Of course there would. If you've got a model of the Earth, and you put it back, if you untilted it and moved it round, you would still get the same effect, because it's still going to be the perfect sphere, isn't it? What difference does it make?
That tilting the sphere thing. Yeah.
Okay, Lawrence. The top is always at the top. Okay, on the story of this heliocentric model, the north is always at the top, and the Earth is spinning around this way, and it's going around the sun too. So as it's spinning this way, that makes the day, and the going around the sun makes the year. With the tilt on half of the year or quarter of the year, the supposed tilt is going to expose the certain angle of the face that's facing the sun at like say the lower half of the globe, and when it's on the other side, the top part now is getting more of the sun. Do you get me?
Yeah, well, that would be exactly the same whether it tilted or not. You'd still have the perfect sphere.
No, it would be the same all the time. Every day would be the same. If you live in the middle, you always get the same.
You try
without the tilt.
If you try it with a little model, I know it's heliocentric rubbish anyway, but if you try it with the model, you'd have different places. If you tilted it, they'd be located in different place relation to the sun. But then another place would take the place of that, and you would get exactly the same effect whether it tilted or not. That's the flaw in that argument. The tilt is a totally flawed argument.
Well, of course it's a flawed argument, but that was the argument that they came up with for how the seasons worked on the spinning globe.
It's stupid.
Well, it is stupid, except if you take John is scratching his head sitting in
It is stupid.
Stupid.
I agree.
If you took away the angle, the 23.4 degree tilt, this God, I wish I had a ball.
Can you imagine that this Earth is like this ball traveling through space, and it does this perfect tilt every year in the.
I happen to have a ball. Okay, this is the baseball signed by some baseball team that whatever. Okay, so without the tilt, we're going to use the natural place you hold the ball. So that would be the 23 as it goes around this sun, blah, blah, the face that's exposed to the sun is going to be different during what side of the sun it's on during that with that angle. Okay. If it was always like this and just going around, okay, then these guys would get full on sun every day and full on night, but every day they would get the same. The sun wouldn't move north and south. It would just be right there on the equator all the time, right?
Right.
Okay. So how would you have seasons?
Well,
How would you explain the seasons if you didn't tilt that ball? That was brilliant, but
if you tilt it, it would be exactly the same. It's just that different places would get more of the sun. That's all.
Well, except you have to add in the going around the sun thing, okay?
It still doesn't change. All it changes.
It does.
It doesn't.
The tilt changes.
No, it definitely doesn't. No.
Okay.
You need to think it through.
You need to like do an experiment where you have a little sun in the middle and you just run around with the ball. You know,
Yeah.
You don't even have to spin it because the spinning only is the day and the night thing. You just have to run around the ball with the face of the ball, and pretty soon you're going to notice that this guy down here is getting face on the sun, and these guys up here are getting less.
Wait a second. I'm thinking about this whole thing again. Hold on. What did they say? They say that the Earth is not only tilted during the seasons, but they also say that during the summer, we in the northern hemisphere are close. The sun is the Earth is closer to the sun, right? Closer to the sun, and so our summers are closer, but they're shorter, and our winters are longer, and we're further away. So that would mean that in the opposite, below the equator, it's a longer summer but a shorter winter. That's right? I mean, it's like the inverse, correct? So they only have like a winter for like a little bit.
Yeah, but there's something they're not telling us here, because
You think?
when you go on the temperature records, they've had temperatures of 100 degrees in Alaska. How do you explain that?
Well, it's the same thing with, let's go back to our little, baseball here, okay, with the 23 degree for thing, okay? There's deserts here, there's deserts here, there's deserts there. That's Australia. They got a lot of desert in Australia, okay? And the ball is spinning and going around the 365 day year sun thing. Okay.
Depends what year you're in.
There's no, with the 24.4 degree, there's no rhyme or reason. Heat, length of day, summer, blah, blah, season, Tropic of Cancer, Tropic of Capricorn, it doesn't matter. Go look where all the deserts are. They're not all like on the equator where you think it'd be like, oh, really hot. I mean, there's high ones, low ones, and medium ones that have no right, and on every continent, right? Isn't there a desert on every continent of some kind?
Except Europe.
There's no desert on Europe.
Well, Rome is a kind of a desert, or
depends what you define desert, but
the desert of the real people.
So there's no rhyme or reason to that. The same thing with the rivers with this 23.4 degree angling thing. Okay, some of these rivers flow north, some of these rivers flow south, some of them flow north in the south and south in the north, and then vice versa, right?
Yeah.
Okay. And people say, oh, but it all makes sense on flat Earth. And they're talking about that circle model, and it doesn't make any more sense there. It does on this angle 23 thing. Okay. It makes no more sense there on it, just as to which one is north or south of the equator, because it's all flat. It's got nothing to do with that.
When we did geography at school, and they're always saying that, when you're on the coast, you get milder climates because you've got the sea air. But if you look at New York, that's quite close to the coast, isn't it? But in New York, you do get some severe winters. But New York's on a similar latitude to places in the Mediterranean. So how would you explain why New York gets these really severe winters?
Because we get the air coming across from the Arctic.
Oh wait, let's go with the lake effect. Yeah. Here we go.
Well, actually, I did live. I did live in Rochester for a while, and boy, no, that lake effect snow brutal. Is serious.
Yeah,
is serious. But it affords you the opportunity to take a day off and like jump off of a third-story building into a pile
Into a
of snow.
bank of
It's
snow.
fun. Yeah, it's fun until you get stuck. But
Okay,
yeah,
so
it's crosswinds. We get crosswinds from the north, and then they swirl around back from the ocean, and so that's why they term it a nor'easter, because it's coming back around from the east, but it's still got that other stuff coming from the
the cold
northwest.
from the north.
Yeah. But I live on a river. But Lawrence, I live on a river, so I live on the east side of a river, the Hudson River, and it's a little nicer on our side. It's a little cooler on the other side. Yeah, it's kind of like how the weather is temperate in San Francisco, even though it's at a northern latitude. It's because it's so close to the ocean. The water keeps everything warm. Well, like that, even just the difference of a river, it's a little bit warmer on the east side of the Hudson, depending on where you are and depending on how the air comes. But yeah, there's that water with the heat mixture. And
there you go.
And all the continents are not the same size, and so you have differentials.
And the air patterns are not the same.
It's a very comprehensive formula.
Realm.
Yeah.
Okay.
Realm.
Lawrence, I have one for you. To consider as an alternative to let's go looking for all this missing curvature thing. Okay. And that is to go and look at coastlines of continents. All the coastlines are registered as sea level at the coastline, correct?
Yeah.
0 degrees elevation, correct?
Yeah.
Isn't that what it's called?
Yeah.
Okay. So shouldn't that be a pretty big screamer because we all know the water stays flat, and even the people who want to go with the water sticks to a globe. Okay. If all coastlines are 0 degrees elevation, then and we know water's flat. How do you consider 0 degrees elevation?
Well, when you go on
water, sea level.
If you go on Google Earth, they give you the elevation on the land masses, but when you go over the oceans, they give you a minus figure, which is where they think the seabed is. So they won't confess.
Oh, so they don't give you any sea level?
No.
Those rat bastards.
Yeah, they'll say minus 2,000 meters if that's how deep the ocean is there. They won't.
Okay, so but am I correct? And my friend Bruce Robinson and I were talking about this in a chat, and that is if the coastline is all sea level, what is sea level? It's 0 degree elevation, okay? Because there's places on Earth where it is below sea level, right? Like Dead Sea is below sea level.
Yeah.
But nobody goes around and compares what is sea level. Do you see what I mean?
Yeah.
On a globe or on a flat plane, either one, which place designates sea level? Which sea? Which coast? Which spot? You follow me? There's got to be one defining sea level or 0 degrees elevation above water in order for all other elevations to be decided upon. A mountain is, 13,000 feet elevation based on what? Sea level? You got an answer for that, John?
No, but I know what you're talking about now. Yeah, you're trying to determine what denotes sea level, like
0 degrees elevation.
Right. I mean, is there some sort of barometric pressure gauge? Is there a physical meter level or something from only one location, a standard location? I don't.
Well, I mean, if you go around a shoreline, okay, let's say you went down the eastern seaboard or the western seaboard of the United States, okay, on that sandy beach that we don't know where the hell the sand comes from. We don't know if it's not fish poop.
Well, the Hudson River goes into
earlier in the video. Okay.
The Hudson River goes into the Adirondacks, and it's at sea level all the way from Manhattan up until at least Albany. It's flat water, and you're going up between mountains and everything. But that Hudson River and any river is always at sea level, just as, yeah. So, I mean,
So what
at some point, it changes where you have the waterfall cresting down from like the really extreme, elevation.
Right.
Yeah.
Okay. So what is the universal elevation on a globe for sea level?
How do you phrase that question? How do you query that?
I don't know.
We need a quantum computer.
What determines sea level? Sea level.
Do you hear me, Watson? Figure that one out, Watson.
People also ask, what is the height of sea level? Is sea level the same everywhere in the world? Where is sea level taken from? How do you measure elevation? The easiest way this may be calculated is by selecting a location and calculating the mean sea level at that point and use it as datum. For example, a period of 19 years of hourly level observations may be averaged and used to determine the mean sea level at some measurement point. What the hell gobbledygook is that? That was like the biggest non-answer for anything I ever read.
Well, or it's a science guy really trying to save his ass with,
Looky here. Here's one called sea level trends. Frequently asked questions. Sea level trend. How do you measure sea level? Measuring sea level, global greenhouse warming. Oh yeah, let's jump that in there. How exactly is sea level measured? Notes and queries. Oh yeah, I'm going to go to the Guardian for this answer. Sure. This got to how stuff works. Oh, they're my favorite. Talk about gobbledygook. Oh, and the National Geographic Society. So there's no answer for what is the height of sea level? Is sea level the same everywhere in the world?
Geographic for some reason.
Where is sea level taken from? How do you measure elevation? Well, I mean, isn't elevation above or below sea level, right?
As soon as you have sea level, you have. But I think maybe it has to do with certain cities, because I mean you establish some sort of 0 point, Mark Twain, I don't know, as it were.
Mm-hmm. Well, so who established it and where do we find it? Do you see what I'm saying? Because if the coast level all the way along the Pacific Ocean side of the western side of the United States, sea level is where it comes up on the sand, right? Where the water hits the land. That's
but
sea level.
You'd have to calculate it at the perfect time of day, because otherwise you have low tide or high tide. So
okay, and that's where they come up with mean sea level.
There you go.
The difference between
okay, gotcha. Between
low tide and high tide.
Okay, yeah, sure, I get it.
But is it the same level of elevation? This is my question. Is it the same level of degree of elevation above the water line all the way? Let's say you start in Alaska and go all the way down the west coast of the Americas to the bottom of South America. Okay, elevation, sea level is sea level.
What would
yes, you got ocean, you got waves and you got higher tides, all that stuff. But there, globe or no globe, there has to be.
Well, there must be a GPS standard.
Okay.
There would have to be a GPS standard.
There has to be a standard to compare which mountain is the tallest mountain in the world. If we're going from sea level, what are you measuring from? Okay. Yeah. It's not just an arbitrary, our mountain's bigger than your mountain. No, our mountain is taller than your mountain and it's just a little bit longer or whatever. People have been comparing mountains because there's mountain climbers for as long as my isn't life really stupid sometimes?
Oh my God.
Somebody will make a video go, no, Lori, it's just you.
You can have sea level on a globe, but if you're looking at a globe, you've got the sticky out bits, the land masses which are at different heights, water surrounding it, which is all at the same level. If you took all the land masses, if you shaved all the land masses off, then everything would be at sea level, wouldn't it?
Have you seen the picture of the so-called globe without all the water on it? That Morphe-looking, shrunken potato-looking, horrible, gloppy mass of looks like a Mr. Potato Head that got left out in too long. It's not globular at all. And so unless I miss my guess, there is no determined calculation for sea level. I mean, what are you measuring from the radius, the core, the center of the globe to the, you know what I'm saying?
Are you talking about the potato gravity map? Are you talking?
The one that
lumpy
spins
one?
goofy, the lumpy thing. Yeah.
But
Okay.
that takes. But when you take a look at that,
I mean, we all know it's bogus, right? Because
but I like to. It's like these other guys that we know that are trying to fit a certain map around a certain. They have to wrap it around something, because if you look at the ocean basins on that potato map, that doesn't make sense.
Right.
Because it's flat. So
some of us trying to wrap the map around a sphere
or whatever.
What is the shape of the sphere, and what is the one-dimensional map going on a three-dimensional? I mean, it's an exercise in
well, I mean, it's a flat observation. They're just basically taking radio signals and bouncing them, and they're creating some, like when you're looking for
I
the
don't
fish
know.
are.
That's the whole point. I don't know. I don't know why we're going through this exercise. But there's scientists who measure cow fart methane, so that's vitally important to life, the universe, and everything. So, but I think it's a valid question. What determines sea level, and what, I don't want to hear about mean sea level, because I'm talking about measuring elevation from, for comparing all these different mountains around Earth. Like Denver, we're the tallest city in America or whatever. Isn't that what they, Mile High City, right? Okay. Mile high from what? You get me? Okay. A mile high from the ocean. From which part? That's a really it's a non-answer too, Lawrence.
Well, no, this is how they do it, Laurie. Imagine that you've got a miniature globe, with some lumpy bits, which are the mountains and things. And then you got, when you get these things, when you have a piece of cheese and pineapple on one of those cocktail sticks. Well, if you stuck all these cocktail sticks into the model globe, then how far up the stick would be from the, if you put a piece of string around it to the next.
Right. So you're talking about the circumference.
That would be how they would work it out. Yeah.
Okay, so that's saying though that I mean, look at all the other things that come into play. Well, it's actually not a sphere; it's an oblate spheroid, and
they should call it sea level. They should call it sea height.
But sea height from what? What I want to know is what is the number? Where is it measured from? And where is the magical beginning of elevation above sea level? That's what I want to know.
I got an idea. Take 3 points. 3 points equals a plane. So you take 3 equidistant points from each ocean, or from, 3 different oceans, and you measure them at, low tide, you measure them at, mid tide, you measure them at high tide. But this way you have it's a more scientific approach of...
Wait, John, measure it from what?
Well, if you can take a barometric pressure measurement from, where the water meets the air, from 3 different locations. I would say 3 different locations, because 3 points equals a plane. And if you want to be consistent with that sort of thinking. But I'm just thinking of barometric pressure. I mean, it might not be able to be sensed or observed on the meters that we have. You might need something that's a little bit more on the smaller scale to measure that, difference, or to catch it right at that, I don't know. Okay. I'm
hearing what you're saying, and I'm following.
Yeah.
But barometric pressure is
that's the only thing that measures height above.
It is altered by temperature, right? So you would have to take this reading at the same temperature. There's a lot of factors here. So have I asked the $64,000 question? Who, where, how did they determine what the hell sea level is, and what is the place that we're all measuring this elevation of all these mountains and what did you call them? Sticky bits? I love your language, Lawrence. You guys got the coolest little, word terms.
This is the way you could
stuff.
prove if you had some money, you'd get
Lumpy bit.
you get two ships to the equator, right?
Okay.
And one ship would drop its anchor and it'd stop, and it would have a wire that was attached to the other ship on a big spool, and it would gradually unwind. And the other ship would continue to sail east or west and continue for 25,000 miles till it went across the barrier, the imaginary barrier, and then it would meet up with the other ship, and the wire would continue to the other ship, wouldn't it? And it would stay the same distance above the sea all the way around.
Well, isn't that what we said about Pac-Man? I mean, at what point does, Pac-Man happen, where if you had 3 or 4 or 5 ships staggered ever so far ahead of the next one, would one disappear into the next day, then the rest saw it poof away? No, it doesn't. I don't think it happens like that. But has anybody ever tried it? Set up an armada of ships in separated. How far can you see over the ocean? A mile? Okay, 2 miles, 3 miles, where you can keep each other in view.
Some very thin, strong wire, super strong titanium wire or whatever. 2 ships.
25,000 miles of it. Woo! That would have to be some serious strong wire and very thin and lightweight.
I'm sure it exists. I'm not talking about big cables. I mean, little.
No, I get you. No, I got you. It would have to be strong. We're not talking about some normal cable, because it would be too heavy to stretch 25,000 miles. But we're getting off on some weirdness. But I agree, that would be an interesting exercise.
Yeah.
All right. So we've done a couple hours, and we said we weren't going to do 3 and 4 and that anymore. So I think we touched on a lot of topics, and I think we could talk exponentially on any one of them, but the ones that I really wanted to highlight were the ones that we're going to get called out for questioning. A, curvature; B, line of convergence; C, refraction. Let's add trying to figure out elevation in there. How do you do it on a flat earth? How do you do it on a globe? There has to be a formula for how everybody arrives at my mountain's taller than your mountain. And the fact that we question all this exercise and energy and repetition being thrown at, where's the curvature? You won't find curvature because it's not there, but you won't see it anyway, because the way that our eyes see creates a line of convergence called the horizon line. Why? Because it's horizontal. If it went up and down, it would be called the vertical line. How cool would that be to all of a sudden we started seeing vertical lines in our vision? How do we know that other animals or insects or whatever don't see that way? Maybe they have a vertical horizon line. And
cats.
So cats, yeah, lizards, maybe. Who knows?
Sure.
It's pretty hard to show through camera photography trickery, affectations. It's pretty hard to show anything other than normal vision, isn't it? Like, I watched a movie last night that had Clint Eastwood in it, who was directing, was one of his last movies, and they were trying to show what macular degeneration would look like looking through somebody's eyes with macular degeneration. And what happens with that is your peripheral vision stays pretty decent, but you just pretty much got a cloud of, you can't see very much in the center. Okay. And you add your 2 eyes together. If one eye's getting it and the other eye's not, then the brain has to pick the better image. And so my point is that we can't know what someone else sees through their eyes, except for maybe some blurriness of a camera, or if you put somebody else's glasses on. If you've never done that, it's pretty trippy. If they especially have like astigmatism or something and you don't, and you put their what looks like Coke bottle lenses on your eyes, it kind of can even make you sick and dizzy. So I don't really know where I was going with that, but the point is, the reason why the horizon line always stays at eye level is because it's your eyes that's making it, and it is not anything other than that. It's not curvature. It's as far as your eyes can see. What do you got, Lawrence?
I was just, I bought these. Well, let me tell you a little story. But you see, I'm doing this thing called, I'm only telling you this as a side story, but there's something quite interesting that I've just thought of as a flat earth thing. But I'm doing this thing called the Great British Scent-Off next week, where I have these are coffee containers. They had coffee beans in, and I've bought 20 of those. And I'm going to put some cotton wool in and then put essential oils in. And then people have to open the top and sniff each one, and then write down on a piece of paper what the scent is, and the one who gets the most gets a prize that I'm donating. But I was just thinking, if the earth was in a barrel, and the barrel was turning slightly, and it was sort of floating on something within the barrel, and everything would still be flat, but then you could have, because the water and the thingies was continuously turning, would that not give you the same effect as Pac-Man, if you can imagine it? If I put some water in
so you're saying if the water is floating in there and the barrel is turning, if it was turning slow enough, you would see the top of if you had stars on the top of the barrel, they would move past you. Yeah. So if the level of the earth was in there and it was floating on water, yes. If the barrel was turning one direction and not rocking, but just turning slow enough, then you would see the sun, the moon, and the stars going overhead, and they probably would even appear to set. It would probably explain the two poles
and
if you were in a barrel.
The water would always
floating.
be moving away from you if it was turning. Mm-hmm. Yeah, I don't know, just a thought.
Okay, that's an interesting thought, though.
Yeah, one
to mull around a little bit. That's where ideas come from, and we're not ashamed to say so. So that's the whole idea here. We just sit around like we're sitting around the coffee table, sipping drinks, sipping coffee, whatever it is, and having a chit chat. And I've had people say, I've had people,
and it would just move around a little.
He's not listening to me. I'm trying to close this show, Lawrence.
All right.
The people say, you guys, your presentations are terrible. We're not making presentations. Should be pretty obvious. We're just free flowing ideas here and entertaining thoughts and discussing open topics. And we're not actually trying to make if we were really trying to make a presentation, we would do it better than that. So that being said, thanks you guys always for interesting conversation and good ideas, and having no fear to just through the brain and out the mouth and let it flow and see what happens, and see some of it evolves into something and some of it just goes into the archives. Sometimes it's pulled out later and goes with something else, and it's like an old shirt you haven't worn in a long time. You get a new pair of pants and suddenly that shirt goes with that new pair of pants. So
how crazy the thought is. You should express it's out there, because somebody might latch onto one part of it. The rest of it might be total crap, but you might get one.
Exactly. And it might turn on an idea for somebody else, and they may take it and solve a huge problem. So good evening, gentlemen, and we'll meet again soon.
Indeed.
That's it.
Good night, guys.
All right.